Alright, so this is video 2 of systems of equations, and this one is going to cover the substitution method of solving equations. So before we continue on to the video, let's talk about what substitution is. Substitution is replacing two equivalent things. Meaning to say, if I have a variable and I say it is equal to a number or to another expression, I can replace the variable in a different expression or a different equation with what I have already defined it to be. So for example, in example 1, in the intro box, I have that x is equal to 5. And then I have the expression 4x plus 6, which means to say this x and this x are the same. So I can essentially replace the x in the expression with what I have defined x to be prior to that, which is 5. So that's what I'm going to do right over here. I'm going to say 4 times 5 plus 6, and that would equal to 26. Okay? Now, in my next example, I've said that y is equal to 4x. So I've defined y to be equal to 4x. And then I have a linear equation where I have said that I have a y in there, which is the same as what I have defined y to be. Which means to say I can replace this y with what I've defined the y to be, which is 4x. So that's what I'm going to do. 6x plus 2 times 4x, and that's going to equal to 28. So I have 6x plus 8x is equal to 28. 6 plus 8 is going to be 14x, and that's equal to 28. Divide both sides by 14. So x is equal to 2. Then I can go ahead, and if I wanted to solve for y, I have defined y to be equal to 4x, so I can replace, I have an x here and an x here, so I can replace this x with what I have just found x to be, which is 2. So y is equal to 4 times 2, which is 8. Okay? And believe it or not, we just solved a system of equations using the substitution method. But let's formally define what it is that we did. The first step is to solve one of the equations for one of its variables, which, luckily for us, that step was already done right up there. Okay? Then we're going to substitute the expression for the variable found in step 1 into the other equation, which we did right here. Then we're going to solve the equation from step 2 to find the value of one variable, which we found x was equal to 2. And then this was step 3. This was step 2. Okay, step 4. Substitute the value found in step 3 in any other equations containing both variables to find the value of the variable, which we did right over here. And then step 5 is to check the proposed solution in the original system. So I didn't actually do that, but we are going to do that with the next set of examples so that you're able to see. So again, example 1, first thing I'm going to do is I'm going to try to solve for one of the variables. So it's not already solved for me, okay? So I need to go ahead and do that. And what I'm going to look for is I'm going to look for a variable that does not have a number, a coefficient in front of it. And the only one that I see, even though it's a negative, is my first equation, and it's that y right here. So what I'm going to do is I'm actually going to solve for y for my first equation. So I'm going to take the 3x minus y is equal to 6. And you can do it in a couple different ways. I'm actually going to add the y and then subtract the 6. So I'm going to have 3x is equal to y plus 6. And then I'm going to subtract the 6. So 3x minus 6 is equal to y. So I just solved for y. So now I'm going to replace the y in this equation for this expression that I just came up with. And that would be step 2. So I'm going to have, and I'll make this equation in green. So I have negative 4x plus 2, and then I'm going to replace the y with 3x minus 6. And that's going to equal to y. And that's going to equal to negative 8. So now I'm going to distribute the 2. So I have negative 4x plus 6x minus 12 is equal to negative 8. I'm going to combine my like terms, so 2x minus 12 is equal to negative 8. I'm going to add 12 to both sides. Negative 8 plus 12. So I have 2x is equal to 4. I think it's 4. Yeah, 4. And then I divide both sides by 2, meaning to say that x is equal to 2. Okay? Now, and clearly I have too much going on here. I'm going to have to move things around. That's all right. I'm going to plug in the 2 for x back into that x value over here. So that's what I'm going to do right there. So I'm going to have 3 times 2 minus 6, and that's going to equal to y. So I have 6 minus 6, which is equal to y, so 0 is equal to y. So my ordered pair is going to be 2, 0. Okay? And I'm going to now check that this is correct. So I'm going to plug it into the original, meaning to say into the original that I was given up here. So I'm going to have 3 times 2, because that's my x value, minus 0, because that's my y value, and that's supposed to be equal to 6. 3 times 2 is 6, minus 0 is 6, so that's true. So that's equation 1. Now let's do equation 2. So I have 4 times 2 plus 2 times 0, and that's supposed to be equal to negative 8. Well, that's going to disappear because 2 times 0 is 0. Negative 4 times 2 is indeed negative 8. So that does work, meaning to say that my solution is indeed 2, 0. All right, so let's go to our next example. Now notice that this next example actually is a little bit less work because we already have y solved for. We're told that y is equal to 2x minus 5, which means to say I can replace the y in the second equation with 2x minus 5. So that's what I'm going to do. I'm going to say 8x minus 4 times the quantity of 2x minus 5. I just made that green, this orange, and that's going to equal to 20. So now I'm going to go ahead and distribute. So I have 8x minus 8x plus 20 is equal to 20. 8x minus 8x goes away, so I have 20 is equal to 20. Now something curious happened here. And what happened is that my variable disappeared. So now I need to kind of look at what I have left. I have that one number is equal to another. And so I need to determine, is this a true statement? Is this number that's equal to another true, or is this number equal to a number a false statement? And in this case, 20 is indeed equal to 20 because 20 and 20 are the same number. So this is a true statement. Which means to say, if we were to graph these equations, we would find that when we're starting at like -5 here, and we have a positive slope, so it would look something like that. If we were to graph both lines, we would find that it is one line on top of another line, meaning to say it is the same line. Therefore, if you have a true statement, then we can say that there's going to be infinitely many solutions. Or you could also say all real numbers. Okay, you don't have to write both, you just can write one. But that would be this particular situation. Okay, so the next equation or system of equations that we have, I do not again have a variable that's solved for, but I notice that this y does not have a coefficient, so I'm actually going to use this equation and solve for y. So I'm going to take the 3x minus y is equal to 4. And I'm actually going to add y to both sides and then subtract the 4. So that's what I'm going to do. 3x is equal to y plus 4. And then I'm going to subtract the 4. So 3x minus 4 is equal to y. So I'm going to plug my expression that I defined for y, which is 3x minus 4, into the y in the second equation, which I'm going to use in green. So I have 6x minus 2, and I'm going to plug in 3x minus 4 is equal to 4. So now I'm going to distribute my 2, so I have 6x minus 6x plus 8 is equal to 4. And again, look what happens. My two variables end up canceling out, and I'm left with 8 is equal to 4. Now again, I have to compare the two numbers. Is this a true statement? And 8 can never equal 4 because they're two totally different numbers. So it is a false statement. Which means to say, if we were to graph these two lines, we would notice that, and this would be like -4 there, and this would be again positive slope, so it would be something like that. And then I don't know what the other one would be. It would have to be, it would be somewhere here, and it would look something like this. Okay, but these are going to be parallel lines, which means say they do not intersect, so we would have no solution if we were to graph them. Meaning to say, if you have a false statement, then that means that you have two parallel lines, and therefore the solution to this particular problem would be no solution. All right, so let's fill out kind of a quick little summary for all of these. Here are my cases. If two numbers equal each other, so if the two numbers are the same, then this means the system of equation has infinitely many solutions. Okay, if the two numbers do not equal each other, then this means to say that the system of equations has no solutions. Just like in example 3. Okay, so that is all we have for this video. Please make sure you practice before you move on to the next video, which would be elimination.